Hi, I'm Martin Sweatman, and in this video I'm going to continue my review of the Younger Dryas impact debate research. Now, so far we've covered the published research from the original Firestone et al. Paper in 2007 through to 2013 in the last video. So in this video I'm going to begin reviewing papers in 2014. Remember where we got to last time. Several indicators of a massive cosmic impact have been confirmed at the base of the Younger Dryas black mat on several continents, including abundant nanodiamonds, impact spherules, and iridium-enriched framboidal magnetic grains. Now, crucially, a spike in platinum has been discovered by Peteev et al. So this was 2013. Now, by itself, this almost proves the Younger Dryas impact hypothesis because the timing is so extraordinarily good. As you can see, the platinum signal is right at the onset of the Younger Dryas cooling to within a few years as far as we can tell. So any impact large enough to have triggered the Younger Dryas cold period, which is a mini ice age that lasted over 1,000 years, must have been huge, or we can expect to have been huge, and therefore we can expect it to have contributed to the megafaunal extinctions and human population declines that have been proposed at this time, as the Comet Research Group claim. Now, here are the papers for 2014. You can see there are several more here, the ones in green, that add further weight to the impact theory, but also a couple of review papers, the pink one here and a yellow one here by Van Hoesel, that continue to dispute the impact theory. Now, this is very interesting because despite all the evidence in its favour, critical review papers continue to be published, and this just shows the strength of opposition to this paradigm-changing science. So leading proponents of alternative theories for the Younger Dryas cold period and the megafaunal extinctions were never going to give the impact theory an easy ride. Now, the first paper out this year is this review paper by Van Hoesel et al. So we're going to review that one in this video. The Younger Dryas impact hypothesis, a critical review. Now, this paper is very long and detailed and comprehensive, all signs of a good paper, and they discuss every aspect of the impact theory and the evidence. But nevertheless, this is a flawed and biased work in my view. Now, it would take me hours and maybe days to take you through it and point out every error, but we don't have time for that. So instead, what I'll do is I'll just point out some of the most glaring problems. Now, remember, it was Van Hoesel et al. Who concocted the wrong date for their Younger Dryas black mat in the Netherlands by radiocarbon dating a piece of charcoal from 5 centimeters above the black mat. Well, this paper continues that theme. Essentially, their tactic in this paper is this: whenever they discuss evidence in favour of the impact theory, it's massively underplayed. Conversely, whenever they discuss evidence against the impact theory, it's massively overplayed. Anyway, let's just have a look at a few examples to see how they get things wrong. Now, like other review papers, they provide a list in their summary and conclusions. They provide a list of the different lines of evidence and whether they are diagnostic of an impact and whether they have been reproduced or not. Now, the key lines of evidence that we've been tracking in these review videos are firstly the platinum, and then the nanodiamonds, and then we have the iridium-enriched framboidal magnetic grains, and perhaps now also we have the impact spherules. So what do we have here in their summary table? Well, for starters, you can see there's nothing here about the platinum signal at all. The single strongest line of evidence in favour of the impact theory doesn't get a mention in this summary table. Well, that's just bonkers. Now, they do talk about the platinum signal in their text, briefly. So let's see what they have to say. So we have to go and look at their summary concerning the iridium and other platinum group elements to see what they say. So here we are. I've highlighted the relevant sentences. So here they acknowledge the platinum signal in this sentence here, but they don't consider it to be important. Really? They say that although Platinum Peak has been found in the Greenland ice sheet and it's related to a meteorite impact, no platinum has been reported at other sites yet. There is thus no unambiguous geochemical evidence that the Younger Dryas impact event took place. Now, the reason the platinum signal is so important is because of the exquisite timing with the onset of the Younger Dryas cooling, as I showed earlier. As I said, this means the impact almost certainly caused the Younger Dryas cooling, and therefore it was almost certainly huge. It has to be to cause a mini ice age lasting over 1,000 years. And remember, it's not just me saying this. This was Pete et al.'s argument too in their paper. But Van Hoesel et al. Make nothing of this at all. The exquisite timing is never mentioned once in their review paper. In fact, later in the paper, without referring specifically to the platinum signal found in the Greenland ice, they say that even if a cosmic impact occurs at the same time as a dramatic change in climate, it doesn't mean the impact triggered the climate change. Now, this is not a scientific statement, and here's why. Science isn't about proof, it's about probability. It's about finding the most likely explanation for observations. So when two extremely rare events, like sudden massive climate change, the Younger Dryas climate change, and a cosmic impact occur practically at the same time, as far as we can tell within a few years of each other, the probability they are not causally related is tiny, because they're both such rare events. So in probabilistic terms, in other words scientific terms, we should conclude it is almost certain the impact caused the climate change. And to give no weight to this at all, to this exquisite timing, is to take an unscientific position which disregards the probabilities. And it's probably the biggest flaw in this paper, but there are many others like it. So let's go back to the summary table and see what they have to say about the nanodiamonds. Okay, now they've got 3 lines for the nanodiamonds. It's 3 different kinds of nanodiamonds in their summary table. Now these two, the Lonsdaleite and the N diamond, are fairly controversial forms of diamond. There is still active debate in the research literature as to whether these forms actually exist. And they are included here because it's thought they only form under even more extreme conditions than regular diamond. And remember, even regular diamond is normally formed under conditions of fairly high temperature, say around 2000 Celsius or so, and extremely high pressure, around 100,000 atmospheres. So that's the kind of pressure you get deep within the Earth, but not anywhere near its surface, except perhaps in physics labs or very transiently in a volcanic explosion. Now the same must be true of nanodiamonds, because the only difference between regular diamonds and nanodiamonds is size, which also means time. Okay? Nanodiamonds can be formed very quickly in an intense explosion, for example, and this is known, whereas large diamonds need these extreme conditions to be maintained for long times so that the nanodiamond can grow and ripen into a large regular diamond. So what do these guys have to say about the nanodiamonds? They agree they occur in the Younger Dryas boundary, and that's this plus here, so it's found in the impact layers. And they agree that at least the cubic nanodiamonds have been reproduced. But then they say they are not diagnostic for an impact. In other words, they can have other causes. So what other causes are they suggesting? We have to read through their summary text of the section that deals with nanodiamonds to find out. So let's go and find that. Okay, so here's their summary about the evidence for the nanodiamonds. They say, although the occurrence of the cubic, the normal diamond, in other words, occurs at the Younger Dryas boundary, the occurrence of the N diamond and the Lonsdaleite is still questioned. Okay, fair enough. Then they say, in order to use the occurrence of the cubic diamond as evidence, it is thus important to discuss the possible origin of these nanodiamonds. So they go on to discuss the possible origin, and they say, yes, they can be produced by meteorites, which are known to carry nanodiamonds, some of them, and presumably comets too. They also say, yes, that nanodiamonds can be produced by a cosmic impact. Okay, they go on to say that nanodiamonds can be produced by volcanic explosions. But then they admit that there is no evidence of any volcanism in these Younger Dryas boundary layers. So essentially that rules out volcanism, and they agree with that. And they then go on to say that there is a hypothetical possibility that nanodiamonds could be produced by ordinary forest fires. Now let's be clear, there is no way the pressures needed to create diamond or nanodiamonds can occur in a forest fire. The pressures needed are truly immense. Nanodiamonds have never been known to be produced by any natural wildfire, and there is zero evidence for this in the research literature. But they also add that we cannot rule it out in case perhaps some nanodiamonds are eventually found to be produced in a forest fire. This is what they say essentially later in their argument. Okay, so they say, although it's still a hypothetical, it could be validated as a possible origin when, this doesn't make grammatical sense, but when more nanodiamonds would be found in charcoal or other wildfire products. Now, this is not, again, a scientific argument. This is like arguing the nanodiamonds could have been produced by dragon breath, for instance. And of course we know dragons don't exist, but according to their reasoning, presumably they would argue that we should keep an open mind in case dragons are eventually found to be real in the future. Okay, so that's a bit of an extreme analog, but they're using the same kind of argument here. It's not scientific. It's requiring too high a burden of proof that science can't provide. If they want wildfire evidence in support of nanodiamonds to be considered, then they need to provide that evidence. Doesn't exist. They then finish with this sentence. If, on the other hand, it can be shown that widespread occurrence of nanodiamonds occur only at specific points in time, wildfires or erosion of a diamond-rich source material would be unlikely. Well, let's just have a look at what the papers that discover the nanodiamonds have said. So this is the paper by Tian et al. That we've previously reviewed, and they say in their results section, no such particles are found in the overlying silt and clay or in the underlying fine sand. So that's indicating a well-defined layer where the nanodiamonds occur. Let's also have a look at the paper by Kennett from 2009, where they find the nanodiamonds, and they say nanodiamonds were not detected above or below the Younger Dryas boundary layer at any site tested. So it appears that we've actually already met this criterion that they were asking for in their conclusion. So really, if we go back to their summary table again, they should really have placed a plus sign in this column. So the nanodiamonds are diagnostic because there's no alternative explanation for their occurrence. So you get the picture. These guys are biased, Van Hoesel et al. Now the same thing happens when they discuss the iridium evidence in this line here. Now their table concerning iridium is a little confusing. They say that iridium has been found in the impact layers. They say it's diagnostic. They say there are no other explanations, but they say it hasn't been reproduced. Well, this directly contradicts their text, where they describe the confirmatory work of Firecat, Haines and Agati. So this should be a plus sign. So we have to read through their text to see what they actually mean and why they think that the iridium is not actually diagnostic of the impact. Okay, so here's their summary of the iridium evidence. They say, in summary, although Firestone et al. Report peaks in iridium concentration at some of their sites, other researchers were not always able to reproduce these results. Notice that the bias in the phrasing there, most researchers were able to reproduce the results. It was just Paquet et al. Who couldn't. And in fact, even that is incorrect. If you remember, if you go back to one of the earlier videos, Paquet did reproduce their results. It's just that they plotted the wrong data, or they plotted the data incorrectly. The key thing is that the iridium seems to be bound within the magnetic grains. They then argue that the iridium peaks do not necessarily indicate a cosmic impact, citing Haines and Agati. Now, what do we know about these papers? We've reviewed them already. We know that the conclusions that Haines made was wrong, because we know from the paper by Firecat et al. That Haines' conclusions were incorrect. So you have to see an earlier video about that. and we know that therefore that the magnetic grains found at the Murray Springs Black Mat site were very likely produced by a cosmic impact. That's what Firecat is claiming. Moreover, if we think about the Pagati paper, we know that the argument put forward by Pagati, let's go to their paper. So this is the Pagati paper where they look at multiple black mats in different sediments. So the argument put forward by Pagati, which is that because there are several similar black mats with a range of dates, that the Younger Dryas black mat was unlikely to have been caused by an impact. We know that this is not logical, since it could be that many other black mat sites, perhaps all of them, were also produced by cosmic impacts. Indeed, the theory of coherent catastrophism, which we discussed in an earlier video, on which the comet impact scenario is based, suggests there shouldn't just be one impact all alone. There should be evidence of multiple impacts. That's what the coherent catastrophism is telling us. So this statement by, or the conclusions of Pagati are wrong, and therefore the statement by Van Hoesel et al. Is also wrong. In fact, this is quite a frequent tactic that Van Hoesel et al. Use. They frequently cite the paper by Pagati as evidence against the impact, and we know that that's incorrect. Now, regarding the work of Firecat et al., so that was where they cited Haines, and of course it was Firecat et al. Who contradicted Haines' conclusions and said that the iridium-rich magnetic grains at Murray Spring sites were almost certainly produced by a cosmic impact. So what do they have to say about Firecat et al.? Let's go and look at the relevant section. Okay, so here we go. This is the section where they discuss the work of Firecat et al. They say, well, the framboids typically consist of spherical clusters of these microcrystals and can have a wide range of possible origins, such as algae activity or anoxic conditions, and are thus not indicative of impacts. Well, that's fair enough, but the magnetic grains found by Firecat et al. Were rich in iridium, which are diagnostic. They then say, however, Firecat et al. Plotted in a graph and compared with known impact material the chemistry of these Younger Dryas boundary spherules, and that it does not overlap with that of the plotted impact material. Okay, so we have to now go and look at Firecat et al. They're basically claiming that Firecat et al.'s plot comparing the chemistry of the particles they found in the Younger Dryas black mat with known impact materials doesn't agree, or they're inconsistent with each other. So here is the plot that they are questioning. Now, all of these symbols here are known impact materials, and Firecat et al. Have drawn in this rough guide to sort of guide the eye as to the region where, if you found spherules within this region, then that would be indicative that they also have an impact origin. Now, they don't actually plot in this, they don't actually plot here their own particles, which would have been helpful. So you have to go and look at their tables previously in the paper. Here they are, sort of side on. So when you look at their tables and plot those data on this plot, you'll find that you get points that more or less fall along this dotted line. So actually, Firecat et al. Are correct. The composition in terms of the silicon and iron, okay, that's on that axis, the iron silica composition of their impact particles in the Younger Dryas, of the particles they find in the Younger Dryas black mat, are consistent, according to their plot, with other known impact materials. So I don't understand how Van Hoesel can claim otherwise. That seems to me, again, to be a mistake. So when we go back to their summary table, this should be a plus, as we've already discussed, and therefore this confirms that an impact took place on the iridium item alone. So you see how Van Hoesel keep getting it wrong in a way that's always biased against the impact theory. Basically, we can't trust them to get anything right, so I don't think we need to keep going with their review of the geochemical evidence. We've already discussed the most important signals and found that their review is lacking with significant errors. Now, in the remainder of their paper, Van Hoesel et al. Discuss the research concerning continent-wide wildfires, megafaunal extinctions, human population declines, the Younger Dryas cooling, the nature of the event, and the dating of the various Younger Dryas sites. And just as before, they get much of this discussion wrong, in my view. But we don't have time to go through all of this, as I say, it would just take far too long. However, whilst I've been very negative about most of this review paper, one area where I think they do pitch their discussion well is in questioning the age control of the sites tested by the Comet Research Group. So evidence for a cosmic impact has been found at over 20 sites by the Comet Research Group, but only about half of these sites are confirmed to have an age consistent with the expected date of the impact, and only about half of those again are accurate enough to be confident they can be directly linked with the impact event. Now, they produce a nice summary of this information in this table, which must have taken quite a lot of work to produce, following the citation trail back for each line of evidence to find the original data for the age of the Younger Dryas black mat at each of these sites. Now the yellow highlights are mine, so I've highlighted all those sites in this column where there is potentially a problem. So in many cases, these highlighted cases refer to where there is no proper age depth model for the Younger Dryas or for the black mat in that location. So these really shouldn't be used by the Comet Research Group to evidence their theory. Whilst it's fine to investigate these sites, they are not firmly dated to the Younger Dryas impact, and therefore it's difficult to see how they can be used to provide firm evidence for it. Moreover, the yellow highlighted dates in this column are actually inconsistent with the assumed date of the impact. So this data is even more worrying than the yellow highlighted ones here, whereas these have no age control or no clear age control. These ones are actually inconsistent, the highlighted ones, with the expected date of the impact. So let's go through these carefully just to see what's going on. Now actually all of these sites where we have an age produced by a radiocarbon age depth model are reproduced in their plot. Let's just find that. So this is a nice addition to the paper, having this plot. Now the horizontal dashed lines here indicate the range of guesses for the date of the impact event by the Comet Research Group. And in this plot we're looking at raw radiocarbon ages, not calibrated ages, which is actually better. It's better to have the raw radiocarbon age if we're going to compare dates across different sites. Also note the error bars for all of these different sites, all this different data. The error bars here and the width of these grey bars, they're all plotted with an uncertainty of 1 sigma. So to get a better idea of the uncertainty in these dates, we should be thinking in terms of 2 sigma or even 3 sigma, in other words 2 or 3 times the width of these error bars, because of the number of different data points here. There's more than 20. So in our mind's eye we can double or even triple the length of these error bars and the width of these bars. So if we have a look at all this data, these different sites here, and compare with, if you like, Murray Springs, which is the sort of canonical or is the sort of typical Younger Dryas black mat site, we notice that the first problem is with Arlington Canyon. So here we have a bunch of radiocarbon dates measured on charcoal from Arlington Canyon, and these radiocarbon dates look to be too old by around, well, perhaps 200 years compared to the date of Murray Springs in particular. But actually they have underrepresented the uncertainty in this grey bar. So this grey bar is representing the average calculated from this data for Arlington Canyon. And the uncertainty is too low in this grey bar by about a factor of 5. So this is just a miscalculation by Van Hoesel et al. So they've given an uncertainty here at 1 sigma of 10 years, and it should be about 50 years. That's just a simple mistake in there of the formula that they've used. Basically, they divided by 12 instead of the square root of 12, and then they rounded down to 10. Anyway, the point is that this grey bar here is far too thin. It should be much broader. And remember, that's just 1 sigma. If we consider 2 or 3 sigma, then this grey bar actually reaches quite close to the estimated age of the Younger Dryas impact. There's probably a gap of around 50 or at most 100 years between, let's say, the Murray Springs site and Arlington Canyon. So essentially, the data for Arlington Canyon is easily explained in terms of the old wood effect. In other words, the charcoal in this black matte layer at Arlington Canyon might have come from an old forest, which would then expect to reproduce these results. So there's not really a problem with Arlington Canyon. We can use the old wood effect to explain that. It would also explain the large scatter in these results. Most of the wood was of an intermediate age, perhaps some was extremely ancient, and perhaps some was very young. Now, this site here in the Netherlands, the Geldrop Astelhut site, was measured by Van Hoesel et al. Themselves. We reviewed their paper in an earlier video. And remember, they included some radiocarbon measurements from above the Younger Dryas black matte. So actually, their result here is wrong by about 30 years. It's 30 years too high. So if we bring this narrow grey bar, which actually should be much broader, of course, this is just 1 sigma, it's perfectly, if we bring it down by about 30 years, it's perfectly in agreement with the Murray Springs black matte. So what other sites do we have? We have the Sheridan Cave, which is fine. We have Teliga, which is fine, and Wally's Beach, which is fine. All of these are well dated and agree reasonably well with the Murray Springs site. But it seems we have some problems with these 3 sites. Lake Hind is too young by several hundred years, and Lommel and Ommen are too old by 400 or 500 years. So what should we make of this data? Well, we know that Arlington Canyon, we know that there's a lot of uncertainty or scatter in the measurements from Arlington Canyon. So we know that a single measurement often doesn't reflect the true uncertainty in the age of the black matte. So for example, it could be an old wood effect, there could be what's known as bioturbation or intrusion from above. That can all create a great deal of scatter in measurements, and Arlington Canyon is a great exemplar of this problem. So a single measurement won't necessarily capture the true uncertainty in the age of a particular site, which is why archaeologists like to create proper age depth models based on, say, 10 measurements or more, which then would capture the scatter and the uncertainty. So because these sites are dated with a single measurement, we can't read too much into that. So while these 3 sites are problematic and can't really be used to evidence the Younger Dryas impact, we should recognize that there could be much more uncertainty in these ages than is apparent from a single measurement. And so we can't rule these sites out. They're not yet actually inconsistent with the expected Younger Dryas impact date, because these are only single measurements. So how should we summarize the data in this plot? Well, we know that the Greenland platinum signal tells us to expect to see evidence for a single massive cosmic event around 12,800 to 12,900 BC. But Van Hoesel et al. Completely ignored this most important piece of evidence in their review. We have well-defined ages for around half a dozen sites shown in this plot that all agree with good accuracy with the estimated date of the impact. Now these sites span the North American continent and continue into into Western Europe, as in Geldrop Astelhut. And extensive impact markers are found at all of them, consistent with a single massive cosmic impact. So logically, it follows for the other black matte sites that, although their timing of their sites can't yet convincingly be tied to the same impact, we can expect they will be when better age depth models for these sites are created. So does this mean that the Younger Dryas impact theory is proven yet? Well, personally, I can't see any other way to interpret this evidence that makes any sense. The only other possibility, I think, is that there were perhaps many much smaller and unrelated cosmic impact events that occurred over perhaps hundreds of years apart. The problem with this view is the timing of the Greenland platinum spike with the onset of the Younger Dryas cooling is so perfect, it means it was almost certainly a single large impact event that took place on a single day. So basically, deniers of the Younger Dryas impact theory are on the wrong side of a very strong probabilistic argument. They are essentially playing the lottery at this stage, and that includes Van Hoesel et al. With their flawed review. If the platinum signal found in the Greenland ice, which is easy to measure and the only platinum signal for hundreds of years, begins to show up at other widely separated black matte sites which have good age control, then I think the case will have been made beyond all reasonable doubt. Okay, well that took a lot of time, but I think it's important to see the kinds of lengths that opponents of the impact theory will go to, and the mistakes that they make, genuine or otherwise, that they make to combat the impact theory. Now I'll review more papers from 2004 in the next video, which will follow in a couple of weeks.